Hello everyone, my name is João Cavalheiro and I work as a team lead on the SUSE Manager team. I've been involved in the SUSE monitoring tools and processes almost since this initiative started, and today I'm going to present about our Prometheus ecosystem, the integration we have with SUSE Manager to set up monitoring components in a faster and secure way. I'm going to start with an introduction to monitoring concepts and tools, followed by some best practices. I will then present some Prometheus large-scale concepts and where they can be used. And finally, I will show how SUSE Manager can help automating and simplifying such setups, which will include a live demo. So the importance of metrics. Monitoring is not only about metrics, but they are the most important part of it. Metrics can give you a heartbeat of your infrastructure, and they can also help you react to problems before they happen. They are the starting point for troubleshooting and help to eliminate hypotheses before you investigate them. Also, metrics can be used to tell how efficiently you are using your infrastructure and applications and provide insights on how your customers are experiencing your service quality, as well as forecasting resource usage. And in the metrics ecosystem, one of the most solid tools nowadays is Prometheus. Prometheus is an open source monitoring toolkit with a very active community. It has a multidimensional data model with time series data and a powerful query language called PromQL. Data collection is controlled by the server using a pull mechanism, meaning that pull data from the monitored systems is obtained on demand. Those systems can be either configured statically or found via service discovery methods. There are quite a few available. Also, monitored systems can be instrumented, meaning that you can, on your applications, add endpoints to expose metrics, or they can run exporters. On some situations, this is convenient because you don't want to change your applications. Most Prometheus components are written in Golang, so it's quite easy to build and deploy those as static binaries and to run them on almost any system. Now, Prometheus is not a logging solution. It stores only metrics. Logs have to be handled separately. There are some good tools for this if you have this specific need on logging, but Prometheus itself is not suitable to work with logs. And also, it has no visualization capabilities. It has a very simple user interface that allows you to do some debugging on queries if needed, but for more powerful visualization, the right tool to use is Grafana. Grafana comes up as a natural complement to Prometheus due to its powerful data visualization UI, and it allows you to combine data from Prometheus with other data sources. For example, PostgreSQL or any other relational database. You can combine data from multiple systems on Grafana, so it does not work only with Prometheus or only with time series databases. Grafana panels are fully customizable, so you are able to generate complex graphs in a very simple way, like histograms, for example. And there is support for a variety of graphs, many example dashboards online on the Grafana website that you can use as building blocks in almost any popular application stack that you need to monitor. This is how a typical landscape with Prometheus and Grafana looks like. In this example, we are using Prometheus to monitor a Kubernetes cluster and to display visual metrics on Grafana and to send any eventual alerts to Slack and email. This is a typical setup for alerting. There are exporters available for all popular application stacks, so it will be quite easy to find one for your particular use case. So you can plug in monitoring almost on any existing system with minimal changes. Any part of this setup can be customized to fit your particular monitoring needs. Like any system, monitoring can also fail. It is therefore important to set up redundancy in your monitoring and alerting systems like you would do on any other mission-critical infrastructure. It is important to monitor health from several sources to make sure that you have checks and balances and to monitor your monitoring stack itself. The preferred approach in Prometheus is to instrument your applications to expose metrics about themselves. Whenever that is not possible, you can always use the exporters I have mentioned before. And a bit more in detail, so this exporter is nothing but a library that helps in exposing existing metrics, like operating system metrics, for example, in Prometheus format. This can also be done via any language. It's plain text format, as we have seen early in the slide about Prometheus. So anything that generates that text format and exposes it via HTTP is a valid Prometheus exporter. In the end, Prometheus and monitoring in general can help you uncover problems, but it will not fix them for you. So having good practices and automation together with good monitoring can have a strong impact on your infrastructure reliability. Alerts are a central part to monitoring. To many, the most important part of it, because they allow you to react on things that happen, or sometimes even before they happen and affect your customers. So as it's not practical to keep an eye on dashboards all the time, you need to set up alerts to know what is going on. When thinking about defining an alert, one should ask a few questions. Is it actionable or is it just informational? How to make it get to the right team? Does that team has the tools, access, and the skills necessary to action and remedy the situation? So it's important to have all those things into account when defining an alert. We should also aim to have as few alerts as possible by alerting on symptoms that are associated with end-user pain rather than all the possible causes. So trying to alert on things that directly affect the users and then investigating and using other metrics to understand the root causes of those alerts. And in the end, alerts are only useful if you can action them and if they are adjusted to your particular organization. So you don't want to wake up your on-call engineer with a problem they cannot fix or escalate. And it's highly relevant to, apart from this, to look at your tools on regular intervals. Many times, no news is not necessarily good news. So it's good to check if everything is actually behaving as it should. Container clusters are a popular monitoring target nowadays. And due to their ephemeral nature, there are some particular aspects to take into account when monitoring containers. The first is to monitor all layers, from hardware to services. Typically, you want to show on dashboards the most important alerts on the service side, but still you want to monitor things like hardware and the operating system to understand how things relate together. So make sure that your alerts show what are the impacts to the end user when something is failing, but that you also have all the other metrics required for troubleshooting. When your infrastructure grows, it's easy to get lost in so many metrics. So it's advisable to configure Prometheus to store only the ones that you really need to operate on your infrastructure. It's also known that no monitoring tool can reach its full potential if you don't know your systems, and on the container land this can become more complicated as you can have many things running. So having very good documentation on what services you have, how they should behave, is crucial for keeping the lights on and to react to problems before they actually happen. The big challenge we have on monitoring is when things become really large. Large data centers can be really challenging and need to be monitored at several levels. Hopefully there are tools in the Prometheus ecosystem that can help handling such large-scale setups. I will go through some of the possibilities and also explain some of the known limitations that we have there. So a federation allows a Prometheus server to run and scrape data from slave Prometheus servers. From another Prometheus server where time series data is, there are two general cases where this usually happens. The most common one, which we see on this slide, is the hierarchical federation. This resembles a tree and has a high-level Prometheus that here we call the meta-Prometheus that is collecting data from the Prometheus servers underneath, aggregating that data, and this is usually used for graphing, alerting, and other things that you want to do on aggregated data. So this server will collect data, and you can, in this case, customize the data that you collect from the Prometheus slaves. Typically, you don't want to collect all the data, otherwise this server will be really loaded. And with that, you can tune things to work beyond a certain scale. I would say that most cases that are not really large would fit into this setup. And although you can have multiple layers, the common setups only have 2 layers, as we see here on the picture. There is also the cross-service federation. On this second scenario, which is a bit less common, the main target is high availability. You can use this, for example, for sanity checks. One example would be if you have a proxy running in front of a web server and those are monitored by 2 separate Prometheus instances, you can have them cross-checking to validate if the number of requests is the same, for example, to make sure that they are functioning as expected. And you can also use this for alerting, for having high availability on alerting. And this is, again, the most common use case of this setup, to have more than one alert manager running and to be able to run AJ on that service. It's also a characteristic of Alert Manager to automatically do deduplication of alerts. So if you have two Prometheus servers sending the same alert to Alert Manager, it will handle those and make sure you don't get any duplicates. There are some known limitations on the federation and in Prometheus in general, being that the biggest one is how much data can be handled by a single machine. When you run a federation, there is always a top-level server, and if you route all the data to that server, well, you will have limits on how much that one machine can handle. Also, Prometheus does not provide a solution to query data from multiple top-level servers. Even if you have those servers running as separate federations, they do not communicate with each other, and you cannot query them all together from one to the other. So, also due to how it works, the federation will pull data with some delay. So first, the slave Prometheus servers collect data from the systems, then they are scraped by the top-level Prometheus server, and this can, depending on how it is configured, have a certain delay. And if you need real-time responses, then this might be problematic. Also, in terms of long-term data storage, the time series database in Prometheus is designed for high volume and short retention time. The default is 15 days, so it's not a good idea to try to store a whole year worth of metrics on Prometheus. And also, federations can be hard to configure. Things like SSL and encryption need to be done with third-party tools. And if you want more advanced things like doing metric downsampling and allowing metrics in the past to be recorded with less resolution, which is an interesting use case, you cannot do it with Prometheus out of the box. You'll have to use other tools, like the ones we have here, which are large-scale extensions to Prometheus. We have Cortex from Grafana Labs, M3 from Uber, and Thanos. Those are three of the most popular ones. And in general, they allow you to do horizontal scaling, to take Prometheus beyond its natural behavior, to do things like metric downsampling, variable resolution, more durability. So all those solutions support additional time series databases to be plugged in. So it's worth taking a look if you are looking for something that goes beyond what a Prometheus federation is able to do. So now entering SUSE Manager and how SUSE Manager can help putting the pieces together. SUSE Manager can help you automating your monitoring in a secure and easy way. The central role of SUSE Manager in the monitoring infrastructure is to provide configuration automation, and this includes centralizing and simplifying how to set up Prometheus exporters on managed systems. And you can also centrally define which systems, which alerting rules you want to use, and you can also use SUSE Manager to deploy pre-built Grafana dashboards. SUSE Manager also includes some self-help capabilities using the same components, so you can monitor the server itself. And you can set up your monitoring server with Prometheus and Grafana only with a few clicks. And on top of this, you can also use the provided dashboard templates to get started with your monitoring infrastructure very quickly. We have recently added support for federations, so you can now also add your existing Prometheus nodes to a central setup so that SUSE Manager manages his own systems and also collects metrics from Prometheus servers that you might already have running on your existing infrastructure. With the functionality provided by SUSE Manager, monitoring components can be set up in a secure way and using official SUSE packages, which are secure and have been gone through a lot of tests that make sure that they are reliable. SUSE Manager uses salt formulas for configuring monitoring. So when you want to configure monitoring on your managed systems, you are using a mechanism that is already familiar to all SUSE Manager users. In a nutshell, salt formulas are pre-written salt states that can be used for tasks such as installing a package, configuring and starting a service, and many other common tasks. In monitoring, SUSE Manager also acts as a registry for service discovery, which means that it's able to provide through its existing API information about its systems which are monitored, which groups they belong to, and other useful metadata that you can use on Grafana dashboards to do some filtering, to do some aggregation. So there are quite some labels that are added there that extend the standard Prometheus labels. In SUSE Manager 4.1, there is also support for adding existing Prometheus servers in the federation, as I mentioned previously. And on top of this, we'll have a new pre-built Grafana dashboards to operate on those clusters and alert templates that are ready to use. Coming next, we'll have a metric collection from clusters, namely CASP, but also generically you can scrape other clusters as long as you use the federation mechanism and you have a Prometheus server running there. This is a quite common setup on Kubernetes. And we will also introduce a reverse proxy solution to allow monitored systems that are running multiple exporters to automatically expose the metrics from those exporters on a single port, which simplifies things like firewall setups. Also, service discovery is going to have some improvements, namely in terms of performance, to allow it to scale beyond thousands of nodes so that you can use this in really large-scale setups. And on top of all this, we'll continue adding support for additional exporters and more dashboard templates. Next, I will present a demo where you'll see SUSE Manager creating a monitoring setup in a few steps.
Hi everyone, welcome to SUSE Manager. SUSE Manager is a powerful infrastructure automation tool. It is simple enough for everyone in your team to use and powerful enough to manage complex and large infrastructures. In this demo, you will learn how SUSE Manager can be used to automate the setup of a Prometheus-based monitoring stack. Our demo landscape has about 20 registered systems running different base operating systems and also some system groups. To do configuration in SUSE Manager, we use salt states. With salt states, you are able to define a state in which a system should be based on YAML syntax and which covers which packages should be installed, which services should be running, and which files are to be deployed, among other things. The global configuration that includes all the states to be applied to a given system is called the high state. Since those can get big and hard to manage, SUSE Manager provides salt formulas. The formulas are no more than pre-written salt states that take parameters and generate a configuration that is then included in the high state of a system. Using the monitoring formulas you see here, I can, for example, quickly enable the node exporter on a given system. Once I save the formula, I can access the configuration settings, and I'll use the defaults here. So I will enable the node exporter. I will use the default arguments to have it running on the standard port 9100. I will save this formula and apply the high state. Once the high state application completes, I'll be able to browse into this system and check that the node exporter is actually running there. As you can see, we have here the metrics endpoint now available. Also, when we get back to the system list, we see that this system now shows up with the monitoring entitlement. It means that it has at least one exporter installed. Now, to be able to do something with the metrics that this system is exposing, we need to collect them. So next, I will show how to install a Prometheus server also using salt formulas. To set up the monitoring server, I'm going to use the Mon server machine, which is running on a standard SLE15 SP1 setup. To install and configure Prometheus on this machine, I will use the Prometheus formula. The Prometheus package we ship with SUSE Manager includes a service discovery component that allows Prometheus to self-configure the list of targets from which metrics are going to be collected based on information provided by the SUSE Manager server. That information includes which exporters run on a given system and which metadata was configured for those exporters, like for example, the port they run in. We also want to make sure that as part of this initial configuration, this option, monitor this server, is checked. This will make sure that our SUSE Manager server will also be monitored, and this is default for the formula. Once we fill in our API credentials, which will be required by the service discovery component, we can save the formula and we can apply the high state. Once the high state application completes, we will be able to access the Prometheus server running on this system. This should be fast. The default port for Prometheus is 9090, and we see that we now have our Prometheus server up and running. On the list of targets, we see the system that we first configured, this Minion SLE12-1 system, and we also see 6 endpoints running on the SUSE Manager server, which are used to collect self-health metrics. We also see that the monitoring server itself is also monitored. So next, I will show how the node exporter can be added to all systems to have all our infrastructure monitored. To have all my systems monitored with node exporter, I can apply the same formula I used before to a system group. For this purpose, I'll use the all systems group, which contains several systems using different base operating systems. The procedure is similar. I will enable the formula, I will apply the high state, and what this will do is apply the high state with this formula enabled to all the systems that are part of the group. I'm going to use the default settings again, as you can see here, and I'm now going to apply the high state. So once this high state completes, I'll be able to see all these systems in the Prometheus list of targets. They should be showing up right now. As you see, many of them are still in the unknown state because Prometheus still has not collected the metrics the first time. So we'll get back to it in a moment to see if all our systems are up. In the meantime, I'll show you that through activation keys, you can enable monitoring on systems automatically when they are onboarded. On this example key, you see that we have an add-on system type, which is monitoring. And if you enable that, together with this option to deploy configuration files to systems on registration, whenever you use this activation key to onboard the system, that system will automatically have monitoring enabled with the default node exporter installed up and running. We can now go back to Prometheus and take a look at our list of targets. We now see that all our monitored targets are up. So the full list of systems that we have in SUSE Manager is now monitored with Node Exporter. Prometheus is also able to generate alerts. On this demo, I have configured a very simple alert that fires whenever a system is down for 1 minute. You can see here that the alerts are written in the same language Prometheus uses for queries, which is PromQL. And now to test this alert, I will power off one of my systems. I will pick a random system here, and I will execute a salt command to power off that system. Once this command is executed, I will be able to see that this system not only shows up as down in the list of Prometheus targets, but that also an alert rule should be evaluated. And when that happens, we should also be able to see the alert rule in Prometheus. So first, looking at the list of targets, we see that now our system shows as down. And soon on the list of alerts, we can also see that there is an alert active mentioning that there is a system down. Typically, you'll want to configure an alert delivery mechanism such as email or Slack to get those notifications when something goes wrong. This is done in the Alert Manager tool, which is shipped together with Prometheus. We can take a quick look at the Alert Manager UI, which is running on port 9093. You can see here on Alert Manager that there is this active alert. It can display more info, like the message that in this case is very simple, just mentioning that an instance is down. And Alert Manager can also be configured to deliver those alerts via email, via Slack, via any other option you want. Actually, there is a client tool for Alert Manager that can be used in the shell, which allows you to completely customize the way you handle alerts. I will now add Grafana to my monitoring stack. I will again use my Mon server system, and as before, I will use formula to set up Grafana. This formula requires only basic input for a functional setup. So in order to have Grafana up and running, we only need to set up the default credentials for the Grafana UI. Let's use something simple, admin, and the data source that will supply Prometheus data. Since we are running Prometheus on the same machine, we can use the default value here, which points to localhost. So to have Grafana running, now I just need to apply the high state. And once the high state completes, I will be able to browse to my Grafana URL, which will be running on this machine, and see Grafana up and running. Grafana by default runs on port 3000. So as soon as we browse to port 3000, we see that we now have Grafana running. And I would like to quickly show you two of the dashboards that we are shipping. The first is a dashboard for the SUSE Manager server itself, which is used for self-help. You can see that apart from the basic metrics about the hardware and the operating system, we also have some insights on how the server is performing in terms of JVMs, database, and how loaded our Taskomatic scheduler is, for example. We have also included a dashboard to show insights on your client systems. In this dashboard, we can see the list of all systems that we are monitoring. And if you want to filter out the systems, this dashboard includes this drop-down here, which has the list of groups that you defined inside SUSE Manager. So if I want to take a look at my SLE 12 systems, I select it here from the groups. And as you see now, we only have SLE 12 systems listed here. You can also see that on this top panel, we have an active alert. This is about the target that is down, the one we just brought down moments ago while going through the alert mechanism. So on the Grafana side, you can see that it's very quick to set up a working system on top of your existing infrastructure with SUSE Manager. It takes a couple of minutes only to set up Prometheus, Grafana, and to have all your systems monitored. So, thank you for watching and happy monitoring.